Alright then, so for the next few lessons we're going to do some shape work looking at angle properties, and over the next few lessons this will, as usual, I'll take up to sort of grade C and grade B work where we're working with parallel lines and polygons. But this is our first lesson for a while, so I thought I'd start nice and gently, and we'll focus on work that is grade E and grade D challenge, and is certainly just a little bit of a refresher from properties that you would have met certainly in Key Stage 3, but quite possibly in Year 6 in primary school. So the first few pages that we're going to talk about here are just about notation. Okay, so important notation. The box in the corner of a pair of lines notates a right angle, and a right angle is a 90-degree angle. So right angle, 90 degrees, indicated by a box on the angle. Where you have lines that are parallel, those are notated by an arrow. So those two lines are parallel, which means they're traveling in exactly the same direction. They'll never cross. There will never be an angle formed between them. Sometimes you have pairs of parallel lines or more parallel lines. So in this example here, you can see that you've got these double arrows. So every line which has got a double arrow on is a parallel line, and the single arrows indicate that those are parallel lines. And they don't have to be in pairs. There's nothing stopping another parallel line, or a third parallel line, or a fourth parallel line. Basically, every line that's got a double arrow set on it is parallel to every other line with a double arrow. If you had a situation where you had a third group of parallel lines, they'd have 3 arrows, and so on. When you have dashes on lines, that tells you that the lines are of equal length. So that line there is the same length as that there. And in the same way as with the parallel line notation, if you've got different groups of lines that are the same length, then the double dashes or a triple dash will notify that. So those are important signals that you may be presented with in a question. Then we want to focus on triangles, and what I've called here the triangle family. So there are some important types of triangle that you need to recognize. The first one that's indicated here is the Isosceles Triangle, and the Isosceles Triangle is a triangle whose properties are that they have two sides that are the same length. And not only do they have two sides the same length, but also they have a pair of equal angles. And the equal angles are at the base of the two equal sides. So one danger here, and maths teachers fall into this trap as well, is we always draw our isosceles triangle vertically like that. And sometimes then students automatically think that if the triangle is isosceles, it's the bottom angles that are equal. But there's nothing to say you can't have an isosceles triangle which those sides are the same length, and in which case it isn't the bottom pair that are the same, because it's the ones that are at the end of the two equal sides. So be careful with that, don't just assume it's the bottom. An equilateral triangle is one where all sides are the same length and all the angles are the same. And because all the angles are the same and they need to add up to 180 degrees, 180 divided by 3 is 60. So all sides are the same length and all the angles are the same too, and they'll always be 60. A right angle triangle, sides can be any length. One angle is 90, and that's donated by the box. And then the least useful type of triangle that we have to deal with is called a scalene triangle, which you could say hasn't got any properties. Well, it has, but the properties are there's nothing the same about it. So all the sides are different lengths and all the angles are different too. So that's a sort of triangle which we can't do very much maths with. So the next little section now is to do with how we label or describe sides and angles in a triangle. So each point on the triangle where two sides meet is known as the vertex. So here I've got that side and that side, they meet there, so that corner is called a vertex. And these are labelled with capital letters. So A, B, C, P, Q, R, X, Y, Z, and so on. Sides are then described using the letters of the vertices joined by the sides. So that side there is side AB, because one side has got the vertex A and the other has got the vertex B. So it's common sense, really. It's a third one really that you need to have a little bit more thought, because it's not something that you would use regularly. So when we're describing an angle, the angle is described with the vertex containing the angle in the center. So if I wanted to describe this angle here, I would be describing the angle which joins A, B to C. So that angle would be angle A, B, C. We can't just call that angle B, because at angle B there are actually two angles. There's the acute angle there, but there's also the reflex angle on the outside. So A to B to C makes it clear that it's that one that we're dealing with. So just to look at what we're being asked here, using its vertex labels, name this triangle. So that triangle we would write like that, triangle ABC. We're mathematicians, remember, we're lazy, we don't want to write the word triangle when we can just draw one. Which angle is 90 degrees? So this angle is 90 degrees, so we would describe that as BAC, and we would write it with a little sort of hat, little roof above like that, or sometimes you see it as the angle in front like that, but more often than not in the UK we write it like that. Which edge is 6 centimeters? Edge AC. And do the above questions have more than one correct answer? Well, yes they do, because question 1, I've called it triangle ABC, but it could be BAC or CAB or CBA. It doesn't matter, we just tend to write it in alphabetical order. Angle which is 90 degrees, I've written as BAC, but it could be CAB. It doesn't matter as long as the A is in the center letter. So that one could be different. And the edge AC is the same as the edge CA. So yeah, they could have been correctly written in a different way. Second one, which edge is 9 centimeters? So the edge which is 9 centimeters is PQ. Which angle is 50 degrees? PQR. Which angle is 60 degrees? QPR. So as long as the P is in the center, that's fine. Do the above questions have more than one correct answer? Yes. Same reasons. Okay, it could be QP, not PQ, and so on. So that's a little bit about notation. Then we come to quadrilaterals. Now quadrilaterals are four-sided shapes. And there's a number of different quadrilaterals with names you need to know and properties you need to be able to remember. So the first one is a square. One of the first shapes you have described to you in primary school. So a square has got all equal sides and all the angles are 90 degrees. A rectangle also have 90 degree angles internally, and a pair or two pairs of equal sides that are opposite each other. Parallelogram, opposite sides are equal. So it's basically it's a squashed rectangle. If you imagine you put some force on there to push it down. So the length properties follow the same as a rectangle, and then the other property is that the opposite angles are equal. So if you know that that angle is, say, 40 degrees, then it means that angle there must be 40 degrees as well. Then you've got a trapezium, which is what we call it in the UK. Don't call it a trapezoid, it's a trapezium. And that's a four-sided shape with one pair of parallel sides. So here, that side and that side are parallel, but the other two aren't. And when we were doing area and volume, we worked out the area for that was, if that side was A, that side would B, and the distance between them was H. The area would be a half times A plus B times H. Don't need that for this work, but the more times you hear it, better chance you've got of remembering it. A rhombus is basically a squashed square. So just like I took the rectangle, squeezed it to produce that, if you squeeze a square, you get that. So all the sides are equal, opposite sides are parallel, and the same property with the angles. Opposite angles are the same size as well. And then you have a kite, which has got symmetry along one of the diagonals, and the adjacent sides are equal. So that side and that side are equal length, and those two are of equal length, but the blue and the red are of different lengths. And then also that angle there must be equal to that for it to be symmetrical. So hopefully I'm just refreshing your memory with those properties. Then we've got some important angle properties that you need to remember. I mentioned the first one already. It's one you tend to not have a problem with, that angles in a triangle add up to 180 degrees. When you have a pair of intersecting lines, a pair of lines that cross each other, the vertically opposite angles are equal. So that one is directly opposite this one, so they're both 75 in this example. That one is directly opposite that one, so those are equal. When you have lines that all meet at a point, so they're not intersecting like those ones, then the sum of the angles must come to 360 degrees, because that's a complete turn, which is what you get in a circle. And on a straight line, angles that meet at a point on a straight line add up to 180 degrees. And then the final little angle property for today is for a quadrilateral, the interior angles, so the four inside angles in a quadrilateral always add up to 360. So it's 180 for a triangle, 360 for a quadrilateral, because if you imagine that if you join the diagonal in a quadrilateral, you've got a triangle that side, so you've got your 180 degrees, and you've got your triangle that side, which is another 180 degrees, and two lots of 180 is 360. Okay, so with all of that knowledge in mind, and hopefully none of that was new to you, that was all work that you will have met in the distance past of Key Stage 3. Let's take a look at some past paper questions. So the first one is off a maths paper. It's paper 2, so you can use a calculator, and this was set in November 2016. It's question 6, first half of the paper, grade D. It's not drawn to scale, so you can't measure it. Find the size of angle X. So angle X is inside the quadrilateral. So if I knew the other three angles, I could take them away from 360, and that would give me X. But at the moment, I don't know this side here. But I do know that that is on a straight line with 125 degrees. Okay? So if I take 180 less 125, then I know that that angle there is 55 degrees. So now, in order to work out angle X, I'm going to have my 360, because angles inside a quadrilateral add up to 360, and I'm going to subtract the 55, the 117, and the 74. And whatever's left must be angle X. So 360 less 55 less 117 less 74 equals 114 degrees. Okay, so 3 marks for that. So hopefully you're thinking, oh god, that was easy for 3 marks. Grade D. Second one is another paper 2, so we can use a calculator. It's another maths question. This is question 2, so this is a grade E question. Alright, calculate the size of each of the angles F and G. Now usually, when you're given a problem like this with multiple angles, it tends to flow that the easiest angle to find first is the first one in the alphabet. So here we're going to need to find F before we can find G. So F, we've got a pair of intersecting lines, so we've got that vertically opposite property. If that is 73, F is also 73. Now once I know that that is 73, I'm then into this triangle. I know the angles inside the triangle have to add up to 180, and I want to find G. So I need to find this angle. How can I find that angle? Well, that angle lies on a straight line with 128 degrees, so that angle is going to be 180 less 128. (52 degrees). So I now know that that is 52. So to work out G, I know that the angles inside a triangle have to add up to 180, and I know one of them is 73, and I know the other is 52. So what's left when I take those off 180 will give me G. So 180 minus 73 minus 52, 55 degrees. And again, 3 marks. Sorry, I'm just drinking a cup of tea. Right, next one, paper 2 again. I can use my calculator. Question 5, borderline ED. But this is an OCW question. So with the OCW question, it means you've got to do some communicating to explain where your answer is coming from. So in this question, you'll be assessed on the quality of your organisation, communication and accuracy in writing. ABC is an isosceles triangle. So they're telling me it's an isosceles, but they're also signalling that by those 2 lines there. And ABP is a straight line, so it's not bending there at all, so I know that that's going to be 180 degrees. AC equals BC, dash dash, and angle ACB is 76. And we want to know the size of angle CBP. So that's the angle that I've got to work out. And I need to communicate how to do that. Now, if you just did the maths for this, you guaranteed those 3 marks, as long as you get it right. So it's the communication that's going to earn us the extra 2 marks. So let's just think through the maths first of all. I know this is isosceles, so because this is isosceles, that angle there and that angle there are equal. So if I take the 76 degrees off 180, what's left must be shared equally between those 2 angles. So by dividing that difference by 2, it will give me that. Once I know that, that angle and that angle lie on a straight line, so they have to add up to 180. So once I know that angle, I can take it away from 180 and work out what angle CBP is going to be. So that's what we need to communicate. So triangle ABC is isosceles. So angle CAB is equal to angle CBA. Okay, so I'm communicating using that notation that I spoke about much earlier. And so CBA equals 180, take away the 76, which equals 104, divided by 2, which is, which is 52 degrees. So CBA is the 180 take away 76, which is 104, divided by 2, which is 52 degrees. So I know that that is 52 degrees, and I know that is 52 degrees. Now ABP is straight line, so angle CBP equals 180 take away 52. Which is 128 degrees. So if you'd have just written 128 degrees, or you've just done 180 take away 76 divided by 2 is 52, 180 divided by 52 is 128, 3 marks. If you'd just done a little bit of explanation, recognizing that because it's isosceles, those are equal, and because it's a straight line, they add up to 180, that gives you the extra 2 communication marks. So if you don't think you can communicate, but you can work out the answer, don't skip it. You're still going to get at least 3 marks. Maths paper 1, so this is a non-calculator paper. Question 7. We're on the grade D pushing towards grade C area here. Okay, so it's a high grade D question. And it looks horrible. ABCD is a quadrilateral. Okay, so as soon as I read that, I'm thinking angles add up to 360. ABC is 93. BCD is 122, BCD is 122, and ADC is 85. Points P and Q lie on the quadrilateral as shown such that AP equals AQ. So that length there and that length there are the same, which means I can put those on it to remind me. So that means that that triangle is certainly one of the special ones. It's at least an isosceles. Prove that triangle APQ is an equilateral triangle. You must show all your working. Okay, so let's think about how we can do that. Well, I've got a quadrilateral, so I know that the angles inside the quadrilateral must add up to 360. So I can work out what that angle there is. That angle there is going to be 360, take away 85, take away 122, take away 93. Now this is a communication question, so sorry, isn't an OCW question, so I don't need to worry about that. But what I do need to worry about is that I can't use a calculator for this question. So whereas I could tap that nicely into my calculator, it ain't so easy without. So what I'm going to do instead is add up the angles that I know So the angles I know, 122, 85 and 93. So I got 5, 10, 0 down carry 1, 10, 20, 0 down carry 2, 2 and 1, 3. So I know they add up to 300, so that angle there must equal 60 degrees. 360, take away 300. So I now know that that angle is 60 degrees. Now if that angle is 60 degrees, if it was isosceles, I would do 180, take away the 60, leaves me 120 degrees. So those two have to add up to 120, divide that by 2, and I get 60. So that angle is 60, and that angle is 60, which means it must be an equilateral triangle because all the angles are the same. Alright, so it looks horrible, but once you start making progress into it, things fall into place. And then the final question, question 8, so we're definitely pushing high D, low C here. Paper 2, we can use a calculator. ABCDE is a regular pentagon with center O. It's not drawn to scale, so I can't measure it. Calculate the size of angle X. You must show all your working. The key word here is regular. If a shape is regular, it means all the sides are the same length and all the angles are equal. Now I need to qualify what I mean there, because it doesn't mean that the length DE is the same as the length from vertex to the center. So that length, that length, that length, that length, and that length are all the same, but also the internal ones are the same. So what that means is in here I've got 1, 2, 3, 4, 5 equal angles around a point. So the center angles are going to be 360 around the point, divided by 5, because there are 5 of them, (72 degrees). So I know that that angle there is 72, as is every other angle, but I'm working in this triangle. Because it is regular, it means that those two lengths must be the same as well. So if those two are the same, it's an isosceles triangle. So triangle OCD, ODC, isosceles. So therefore X is going to be 180, take away 72, which is 108, divided by 2, which is 54 degrees. So if you get presented with a question like that, we're going to do more work on polygons next week, which will be slightly different to this type. So with this type, because we've got the center point there, if it was a hexagon, there'd be 6 equal angles at the center, so you divide 360 by 6, and that enables you to work out the angles around the side. Okay, so that's 30 minutes of me going through a few past paper questions and talking about the properties. What I want you to do now in the second 30 minutes is to have a go at the questions on the Google Slides sheet, which are testing basically your ability to do questions like that at grade D and E level. Okay, so good luck with that.